Okay, so we look at another reduction formula that involves the integral of sine to the power n of x dx. Okay, so we need to keep in mind to say for sine, the integral of sine to the power n of x, we can also write it as the integral of sine n minus 1 of x, then multiplied by sine x there dx. So I'm able to write it in any form that I want. The only key thing that you have to keep in mind is that don't change the meaning. Okay, we maintain the meaning because in this case what I've written here and what I've written and what is there is simply one and the same thing. Okay, it's just written in a different way, but the meaning is still the same. Okay, it's more like saying 2 by 3 or saying 3 by 2. It's simply one and the same thing. There's commutativity that is involved there. Okay, so here at this point, of course, we can do the integration by parts, and we can choose any as our u, and I'm going to choose my u to be equals to sine to the power n minus 1 of x. Then my dv will be equals to sine x there. So my du will be equals to my n minus 1. Then the derivative of sine is simply cos x. Then they are going to have your what? Your sine n minus 2 of x. Okay, then your v will simply be equals to what? Minus cos x. All right, so remember to say when you differentiate cos x, you're going to get negative sign. So by that, negative becomes positive. So that's really one of the points we have to pay attention on. So we know that our dv is equals to our dv. We've said our dv is equals to sine x, meaning our v is equals to minus cos x. All right. So we can now say v by u is simply minus cos x multiplied by sine n minus 1 of x minus the integral of uh, we have n the integral of dv no, the integral of du by v. Of course, we have the n minus 1 there, which is simply a coefficient, so I just have to write it outside here, which is n minus 1. Then the integral of we are multiplying this v there by what we have there. And again, I've seen that I have a negative here and I have another negative there, so I can make my life easier by putting this as a positive, because those two I'm going to multiply each other. So we have a cos and another cos, that becomes cos squared of x multiplied by what? Sine n minus 2 dx. Okay, so this becomes minus cos x sine n minus 1 of x plus n minus 1, then the integral of, when I look at that cos there, I'm going to write it in terms of 1 minus sine squared of x multiplied by sine n minus 1, I mean n minus 2 of x dx there. Okay, so what do we have? So we find that if we distribute that, you're going to have your cos x sine n minus 1 of x plus n minus 1, then the integral of, you're going to have 1 multiplied by what we have here. Okay, what are we going to have? You're going to have sine n minus 2. Okay, then what we have here multiplied by what we have here, of course you're going to have a minus, then the bases are the same, so add the powers, that is n minus 2 plus 2, that will become what? Sine n of x dx. Okay, so what do we have in this case? What we end up having is that we have minus cos x sine n minus 1 x plus n minus 1. So I'm writing them as separate integrals. I'm going to have my sine n minus 2 of x here dx, then I have minus n minus 1, then I have what do I have? I have the integral of sine n of x dx. Okay, so what I would want you to observe is that when you look at this part, this part here is simply there, like it's like this part here, and that's what we are looking for. So we're going to correct the like terms. So I know that I know that I have that there, but I have a coefficient there. So you find that when you correct the like terms, and of course you have to factor out this one here. So you can express it in terms of a letter or just the way it is. It's up to you. So here, when I factor out that, I'm going to have my integral of the integral of sine n x dx open bracket. Remember to say when you had to bring this on the other side became positive, so you have a 1 here, so it will be plus you have your n minus 1. We close like that. Okay, so when you multiply this out with what we have inside, you're going to have that part there and what you have here. So this will be equals to minus cos x sine n minus 1 x plus n minus 1. Then you have your what? Your sine n minus 2 x dx there. So what you're going to have is that at this point, that is you're going to remain with if you multiply out, you're going to have your 1 plus n minus 1, of which that will just become n. Okay, that we are just going to remain with n. So meaning you are dividing everything by what? Dividing everything by n. So meaning the integral of sine to the power n of x dx is equals to minus cosine of x by sine n minus 1 x plus n minus 1 integral of sine n minus 2 x dx. We are dividing by n and this side by what? By n, and that happens to be the reduction formula that we were looking for. So that's how you go about that one. Thank you very much for watching.